This is our third problem that we will solve today, and this will be about inclined plane. A block of mass m is at rest on inclined plane of height h is given, m is given, and theta is given. The coefficient of friction between the block and the plane is mu, and mu is also given. Find the normal force acting on the block, normal force acting on the block, and the force of friction. We will follow our steps. Step number 1, write the law. We will use second law in components. F sub x is max, and F sub y is may. Now we need to draw the free body diagram. We need to isolate this block and draw all forces applied to this block. So here is my block. This is angle theta. What are the forces? There is force of gravity vertically down. I hope it looks like vertically down. mg, I'm too close to see that. Normal force is perpendicular to the inclined plane. This is normal force, force of reaction with which the inclined plane pushes on block M. And there is force of friction. So if this block wants to move down, force of friction opposes motion, and it is in the direction opposite to motion. Force of friction. So those are all forces that are applied to this block, no other forces. What we need to do next? Next, we need to choose our coordinate system and write net force in x, net force in y, and find what we need to find. But before we start doing that, let's figure out what is the magnitude of force of friction. Basically, we need to figure out, is it mu n, or we need to find it? Is it critical value or it is not? I will draw the diagram that we draw in our previous problem. Let me do this. I will draw it here. So here is force applied. Here is force of friction. So if there is no applied force, in this case, x projection of force of gravity is down. If there is none, then there is no force of friction. But so if it is on flat surface, nothing. But if I make it incline, then there is component of force of gravity along incline. Question is it large enough to overcome friction? So I have first the block at rest, and then I reach this critical value of force of friction, maximum value of force of friction, which is mu static n. As we discussed in previous video, the object is still at rest, and then I have the object moving. So for moving, I will use different color to make sure that we understand that here it is at rest, here it is at rest, and then it is moving, and when it is moving, then force of friction is equal to mu kinetic n. So let's read the problem again and figure out where we are on this diagram. The block of mass m is at rest. It was given that the block is at rest. So since it just wants to move down, the force of friction is up. That part we figured out correctly. But it's not moving. It's not sliding. X component of gravity is not enough to overcome friction. So we are right here where force of friction is less than mu n. We need to figure out what is its magnitude. Let's do it. So I'm ready to write F sub x, except for one minor thing. We need to know how to break force of gravity in components. And actually, I'm not ready to write f sub x because I forgot to choose my coordinate system. What is my coordinate system? Since this is inclined plane, it's convenient to choose x for this problem along the inclined plane and y perpendicular. This is my coordinate system. Before I start writing net f sub x, we need to know how to break force of gravity in components. And to do that, I will redraw force of gravity. I exaggerate the length, and it has to be straight down. So let's do it again in a better way. So vertically down. Gravity. Now I have my x down. I have my y perpendicular to x. And what I want to do, I want to break this force of gravity in components. We know what to do. I need to figure out my right triangle. So I draw a line that is perpendicular to x. Perpendicular to x. This is 90 degrees. This is 90 degrees. And I understand that force of gravity, this force, will be vector sum of these vectors and that vector. So I need to find each of them. I need to find x and y components of force of gravity. My life would be easy if I know which angle in my, let's call it pink triangle for gravity, which angle is theta. And in order to figure it out, what I will do, I will redraw my original triangle, my inclined plane. So this is my inclined plane. This is 90 degrees. This is theta that was given. Now, if I look at this blue triangle, if this is theta, this is 90, then this angle is 90 minus theta. Now we know from geometry that if I have two parallel lines and they are crossed by the third line, then these two angles are equal to each other. So if this angle is 90 minus theta, then this angle is also 90 minus theta. Two lines crossed by another one. This is 90 minus theta. This is 90 degrees, which makes this angle equal to theta. So we figure it out which angle is theta. I want to remind you about another method to figure out which angle is theta. And for that, you need some knowledge from your geometry class. You need to know that if you have two right triangles, in my case, it is blue, my original inclined plane, and pink triangle for gravity. If you have two right triangles, then angles between perpendicular legs are the same. So this angle theta in my original triangle is between horizontal leg and tilted leg. In my new pink triangle, which legs are perpendicular to these two? Which leg is perpendicular to horizontal? Vertical. Which leg is perpendicular to tilted? This one, which makes this angle equal to this one. So one more time, we figure it out that this angle is theta. So now I'm ready to write the components of force of gravity in my coordinate system. Force of gravity sub x, x component in my coordinate system will be positive, and it is mg, hypotenuse, times sine of the angle which is opposite to the leg I'm interested in. And y component of force of gravity is negative, and it is minus mg times cosine of adjacent angle. This one is now adjacent to y component. So after we know this, now we are ready to write F sub x. What is net force in x direction? I come back to this free body diagram. I have x component of force of gravity, which we just figured out. It is mg sine theta. I have x component of force of friction. We are somewhere here. I don't know magnitude. I don't know the magnitude of force of friction. I just put minus force of friction. And this is equal to 0 because the object, the block, is at rest. So the acceleration is 0. It is 0. I can solve for force of friction. I can find the magnitude of force of friction. But I also need normal force. That's why I will write Fy may. What is the net force in y direction? I have normal force minus y component of force of gravity, mg cosine theta. And the block is not jumping perpendicular to inclined plane. Ay is also 0. The block is at rest. So I have two equations, two unknowns. I don't know force of friction, the force of friction, magnitude of force of friction, and I don't know magnitude of the normal force. From the first equation, force of friction will be equal to mg sine theta. From the second equation, I know that normal force is equal to mg cosine theta. So we found both of them, force of friction and normal force. Problem solved.